Namaskar, my dear friends. Let us talk about a simple switcher 3 ampere. So we have a very popular device for few decades, okay, LM2596. This is one of the most popular device that has been, like being used in several projects like medical devices and other applications. So what we will give you right now is we have five designs. One is 7.5 amperes to 7.5 volt 2 amperes. Then we have 3.3 volts 2 ampere, we have 5 volts 2 ampere, we have 12 volts 1 ampere, and we have 17 volt 2 ampere. Okay, there are different utilization for each of these. So what you can do is you can simply take one of the like a switching regulator or one of the simple switcher and put it in your design. All right, and what we are going to get from this particular project is a complete schematic PDF. We have design guidelines, we have bill of materials, and we have design files from ORCID. All right. So let us start. Like why we are going ahead with this. So this is the data sheet of this project, particular device, and as you can see from the Texas Instruments website, we have simple switcher 4.5 volt to 40 volt. This is the input range, and we have 3 amperes output current. All right. Now the beauty of this particular like a device is it has very like a low number of components that is required to design the regulator. That's the only like motivation to have this particular like IC keep on running for several decades. All right. However, a newer version of this product is available these days with like a smaller size and all these things. Still, I believe this IC is not being replaced till now by many of the like designers. So as you can see, we have like devices in several packages. Like we have we have TO263 package, which is like a SMD package. We have TO220 package of a different pin configuration, and similar to that 220 package another straight configuration. So this has little bit better heat dissipation capabilities, and even this one is being used several places. Okay, so for medical devices and other applications, let me just tell you, generally we have used only in medical devices. That's the reason. However, in home theaters and IPCOs or appliances like like fridges or washing machines and all, you can utilize this particular uh, device. All right. So what we are going to offer you, we will just directly go into the circuit and tell you. So first of all, we have all the five circuits. I have put it in the same design file so that you can have a proper understanding here itself. So 7.5 volt 2 amperes, we have the input voltage up to around like 12 volt input, or from battery you can take it from like let's say 9 volt to 15 volt or something like that, and this will give you an output of 7.2 volt 7.5 volt 2 amperes. All right. So properly chosen input capacitors, output capacitors, and like the inductors, and a feedback circuit that has been designed to regulate the output voltage that is there. This is also having a functionality of switching on and switching on off, like basically the on off control by software. All right. If you do not wish to have this, you can directly sort this by using this jumper. So this jumper can be utilized to sort this. Otherwise, you can directly connect it to ground here itself. All right. So there will not be any need of doing any other job. So similar to that, other you can see next project is 3.3 amperes, 3.3 volt 2 ampere. So 3.3 volt 2 ampere, same way we have the input capacitance, we have output capacitors, we have catch diode and everything. This is a fixed version of LM2596, LM2596, and we have the output of 3.3 volt 2 amperes. All right. So there is no like on off control. If you wish to, you can incorporate the same design like this here. All right. Going back to the next design, we have 5 volt 2 amperes. So 5 volt 2 amperes, same way. We have the inductors, we have output capacitors, we have input capacitors, and we have like output of 5 volt 2 amperes. Similar to that, we have the next design of 12 volt 2 amperes. Okay, so you can have input of like around let us say 15 volt to let us say even 30 volt, you can go ahead. So generally these days, like a 15 volt regulated power supplies are there, or 24 volt supplies are there. So these two voltage ranges will be actually easier for you to incorporate here at the input, and we will be getting output of like a 12 volt 1 ampere, not 2 ampere, it is 1 ampere. Okay. Coming back to the little bit higher voltage range, so basically this voltage is utilized for your like motor drive, maybe a stepper motor, or several other applications in medical devices. So for that purpose, what we have done is we are going to have a 17 volt 2 amperes output, and these are the like output capacitors, input capacitors. We have put feed forward capacitance as well, and we have catch diode. The beauty of this is like we have put one like enable signal as well from the microcontroller or something like that you can utilize. So whenever this goes high, it will be switched off. So this was all about the circuit that we have given you, like 5 circuits for different voltage ranges and all these things. However, now coming back to other parts, we have like design guidelines. As I explained you, same thing will be like given to you. Now talking about bill of materials and design files, as we can see, let us open bill of material. All right. So as you can see, we have the bill of material. All the like parts have been put in the same bill of material, so that all the 5 regulators you can utilize. So whichever section you need, that only you can take. Those components only you need to purchase. All right. Now coming back to the bill of material, we have item numbers, we have quantities, we have reference, we have parts. Parts you can see like what is the microfarad, what is the voltage range, and all these things are there. Then we have like manufacturer part number, and then we have description, and whether it has to be assembled or not assembled, that also information is there. So anyway, all the parts have been assembled on the board, so that's the reason none of them is NC. All right. Then we have properly made PCB footprint naming, so that you can have a proper understanding from the PCB layout design point of view, and it will be easy for them to put it. Now you can see we have almost all the devices, like 2 devices are like adjustable, which is actually generating your 7.5 volt and 17 volt, and rest 3 are there, which is 3.3, 5 volt and 12 volt are used as fixed version of LM2596. Okay, good. So this was all about like this thing, and if you wish to, these are the actual part numbers for this, so we can replace here like this. All right. So these are the like complete part numbers and everything that is there with you. If you quickly see the circuit that is there in the ORCAD, so as you can see, we have the ORCAD circuit here, and you can see 7.5 volt 2 amperes. Then we have uh, like 3.3 volt 2 amperes. Then we have 5 volt 2 amperes, it is there. Okay, then we have 12 volt 1 amperes. Let me just make it 1 ampere as a note. And then we have fifth one is 17 volt 2 ampere. All right. So this is the complete circuit that is there in ORCAD. You can easily take it and you can utilize in your circuit. I totally agree with like like the new designs are available or new ICs are available for this particular purposes. However, this is yet a very like popular and very much used by several engineers because of its ruggedness and its like beauty of having very low number of pin counts. That's the understanding. All right, so if you wish to have this particular circuit, or you have to have like some understanding regarding this, you can reach to the description contacts, and we shall be able to give you any feedback or any other requirements that is needed to you. Thank you.